Hello everyone, welcome to my channel. Now in this video I am going to discuss two problems which are solved based on the concept of constraint motion. Now constraint means some fixed boundary conditions, so motion which is under some fixed boundary conditions. Now suppose this problem, we have to solve this problem. The problem is like we have two pulleys, two identical strings passing over the pulleys. This is the common end of these two strings. It is connected to a load of mass m. These are the two free ends. The free ends are pulled downward with equal velocity v. Now the question is, with what velocity this block will rise up? This angle is theta. Okay. So now we have to identify the constraint condition, the fixed boundary condition. So now if you see this, there is a right angle triangle here. So there is a right angle triangle here. Now in this triangle, this angle is theta. Now let's say this distance is k, this is x, and this is y. So this, for these triangle, three sides we have marked it as x, y and k. Okay, now if we use Pythagoras theorem, we have x square is equal to k square plus y square. Okay, now see, when this block moves upward by virtue of this pulling the two ends of the string, the value of x, this length will change, this length will also change. So x and y will change, but this length will remain constant. K is constant. So if I find the rate of change of this length and this length, so if I differentiate this equation with respect to t, x square will be twice x dx by dt. Since k is constant, this length is constant, it will be differentiation of constant is 0 plus twice y dy by dt. Okay, so that gives dy by dt is equal to x by y dx by dt. Okay, x by y dx by dt. Now in this right angle triangle, how much is cos theta? Cos theta is base by hypotenuse, so that is y by x. So that means x by y is equal to 1 by cos theta. Okay, now what is dx by dt? Dx by dt is the rate of change of this length. Okay, now rate of change of this length of the string is equal to the velocity with which the string is being pulled. So that means this quantity dx by dt, this is equal to v. Okay, and dy by dt, what is dy by dt? Is the rate of change of this length. Now rate of change of this length is the velocity with which this block rises up. So that gives velocity of block is equal to v by x by y is cos theta. So v by cos theta. So this is the velocity with which this block will rise up when the two ends of the strings are pulled in the downward direction. Now let us see one more problem based on this concept. Suppose this is a horizontal smooth surface. This is a block of mass m. This is a string passing over a pulley, and this is the free end of the string. The string is passing over the pulley and this is the free end of the string, and this free end is pulled with velocity v. Suppose this angle with the vertical, this angle is theta. So we have to find again the velocity of this block vb. Okay, now the condition is the block should not leave contact with the ground. The surface is smooth. So again here we see that there is a formation of right angle triangle. Okay, now this is k, this is, suppose this length is x, this length is y. So again if we apply Pythagoras theorem to this situation, this is base, this is perpendicular, this is hypotenuse. So y square is equal to k square plus x square. Now again we see that when the block moves in this direction, the value of y changes, the length of x changes, but this value k remains constant. So again this term is constant, this is constant. So if I differentiate this quantity with respect to time, what do I get? I get twice y dy by dt is equal to twice x dx by dt, twice x dx by dt. Okay, so dx by dt is equal to y by x dy by dt. Now what is this dy by dt? Dy by dt is the rate of the change of this length. It is equal to the velocity with which the string is being pulled. So this quantity is v. What is y by x? Y by x. How much is sine theta? Sine theta is x by y. Sine theta in this triangle, x by y. So y by x, it will be 1 by sine theta. 1 by sine theta. Dx by dt, what is dx by dt? Is the rate of change of this length. Rate of change of this length is equal to the velocity with which this block moves. So that means this quantity is Vb. So this Vb equal to how much? This is 1 by sine theta into V. So this is V by sine theta. So this is one type of constraint motion. There are other types also. So this video was to discuss one particular type of question, and the first example which I have discussed, this question is given in your Concept of Physics by H.C. Verma. So I hope this concept is clear to you, and if you have any doubts in these concepts, you can give your doubts in the comment box below. I hope this serves the purpose. Good luck.